Section 2.3 is titled More About Constant of Proportionality. Please make sure that you title your notes and check Canvas to make sure you are on the correct notebook page. But our goals today are to find the constant of proportionality from the information given in a table, and also find any missing information in a proportional relationship using a table. So today we will be solving more problems that involve proportional relationships using tables. Our warm-up today is called equal measures. So I'm going to show a long list of numbers and units, and I would like for you to record as many equivalent measurements as you can. You can reuse numbers and units more than once, but not within the same measurement. So here's an example. 30 minutes is equivalent to a half hour. So if on the next screen you saw minutes and hours, and you saw the number 30 and the number 1/2, and you could say that 30 minutes is equal to a half an hour. So here's the list. Go ahead and pause the video and come up with as many equivalent expressions as you can. Again, the example on the following screen was that 30 minutes was equal to a half an hour. And you can see that 30 minutes and 1/2 hour are all listed here to be used. You can only use units and numbers from this list. You cannot use any other numbers or units that are not on the list. So pause the video and write down as many as you can. Okay, so let's see if you came up with any of the ones from the list here. So one is that 1 centimeter. 1 centimeter is equal to 0.01 meters. And you've learned in Ms. Plickert's class recently that there are 100 centimeters in a meter. So that means that there's 1/100th of a meter in a centimeter. Following along that same pattern, we could also say 30 centimeters is the same as 3/10 of a meter. Again, multiplying 0.3 times 100 would give us 30. Dividing 30 by 100 would give us 0.3. So those two are equivalent. Also, 40 centimeters in 4/10 of a meter. Same concept there. Dividing 40 by 100 or multiplying 0.4 by 100 would give you the other number. Oops, trying to erase. Okay, we also know that 1/2 of a meter, 1/2 of a meter is equal to 50 centimeters. 1/2 of a meter equals 50 centimeters. And that pretty much does it for the metric system. So then obviously the 1/2 hour was equal to 30 minutes. There's also 1 hour equal to 60 minutes. A couple of the harder ones, 1/5 of an hour is equal to 12 minutes. 60 divided by 5, there's 60 minutes in an hour. 60 divided by 5 is 12. So again, 1/5 of an hour is 12 minutes. And then this one's a really odd one. This one's hard for kids to kind of formulate on their own, but 0.4 of an hour is the same as 24 over 60 minutes. So 24 is 0.4 out of 60. So 24 out of 60 minutes would be the same as 0.4 of an hour. There are 24 inches in 2 feet. So 24 inches, 2 feet, those numbers and units are all there. 12 inches is 1 foot. 6 inches is a 1/2 a foot. And another tricky one is that 40 inches is 3 1/3 feet. So if I put 3 1/3 here, and that is 40 inches, so you know that 36 feet or 36 inches is 3 feet. So that would leave you with 4 more inches left over, and 4 out of 12 is 1/3. So did you get any of the ones from the list? I think this lists all of the possibilities, so I'm not sure that there's anything else out there that you could have had that would have been equivalent, because we listed everything that was possible there. So in class we talked about which equations did we have in common. And then we also discussed if you could include more numbers and labels, what would you do, or what would you want to have on there? A very common label that students wanted on there were seconds. And I also had several share that they wanted the number 10 or the number 100, because then you could work between the centimeter and meters again. Okay, so for our first activity, we're going to look at how centimeters and millimeters are related. Today we're going to really concentrate on that constant of proportionality, what it means, and how to find it from the table. So there is a proportional relationship between any length that's measured in centimeters and the same length measured in millimeters. If you've been paying attention in Ms. Plickert's class, you know that there are 10 millimeters in a centimeter. So a millimeter is a smaller unit of measurement. Okay, so we're going to copy this table down in your notebook. So pause the video and get it copied down, and then we'll go ahead and start the activity. So it says if you know the length of something in centimeters, we can calculate it in millimeters. Again, there are 10 millimeters in every centimeter. So in order to get from the left side of the table to the right side of the table, we're going to multiply by 10. So 90 millimeters in 9 centimeters, 125 millimeters in 12.5 centimeters, 500 millimeters in 50 centimeters, and 884.9 millimeters and 88.49 centimeters. Then the question is, what's the constant of proportionality? Well, the constant of proportionality is the number that you multiply the left side by to get the right side. So the answer here is 10. When you're asked what is the constant of proportionality, there are no units there. It's just a number. So again, constant of proportionality is just a number. Okay, let's do another example. Again, pause the video here, and if you want to try to fill the table out on your own first, notice the change in units at the top. Now we're going from millimeters to centimeters. So if you know the length of something in millimeters, you can calculate its length in centimeters. Complete the table. So most students in their mind understand that if there are 10 millimeters in a centimeter, then we should be dividing by 10 to get the answer in centimeters. So 70 divided by 10 is 7. 245 divided by 10 is 24.5. 4 divided by 10 is 0.4. And 699.1 divided by 10 is 69.91. So we are dividing by 10. However, constant of proportionality works a lot like scale factor. We don't use division. So when you're talking about the constant of proportionality, it's always the multiplier. How do you get from the left side to the right side? But remember, if we want to say we're dividing by 10, and dividing by 10 is the same thing as multiplying by 1/10. Remember that concept of multiplying by the reciprocal. So the constant of proportionality here is 1/10. Some students like decimals, so you'll see some students say 0.1. However, it's going to be much easier to work with the fraction, especially then because you can relate the two constant of proportionalities together. So how are these two constants of proportionality related? Remember what they were. The first constant of proportionality was 10, and the second constant of proportionality is 1/10. To get from millimeters or centimeters to millimeters, we multiplied by 10, and to get from millimeters back to centimeters, we multiplied by 1/10. These constants of proportionality are related because they are reciprocals. And you might want to write that down in your notebook somewhere. They are reciprocals. Whenever you have one relationship going one direction and then you go the other direction with it, that same relationship, the constants of proportionalities will be reciprocals. And again, we don't use division. So I know we divide by 10 to get the answers in the table, but the constant of proportionality is 1/10. So to convert from millimeters to centimeters, you can from centimeters to millimeters, you can multiply by 10. To convert from millimeters to centimeters, you can divide by 10 or multiply by 1/10. And again, you will see me use the fraction more often than the decimal. The next activity is called Pittsburgh to Phoenix. So we had a little talk in class first about if someone's walking at a constant speed of 4 miles per hour, how much time does it take them to walk 4 miles? How about 8 miles? At 4 miles an hour, how far can you walk, or how long does it take you to walk 20 miles? 2 miles? What about a half a mile? So at 4 miles per hour, you can walk 4 miles in, the answer, the first one is 1 hour. Hopefully that's what you're saying. 4 miles in 1 hour. You can walk 8 miles in 2 hours. You can walk 20 miles in 5 hours. You can walk 2 miles in a half an hour. And you can walk a half of a mile in how long? Well, if we keep working our way and cutting things in half, again, 4 miles in 1 hour, 2 miles, that's half the distance, so half the time in a half an hour. 1 mile would be a quarter of an hour or 15 minutes. So cut that in half again, a half of a mile would be an eighth of an hour, or half of 15 is 7.5 minutes. So this is that information on a double number line, 4 miles in an hour, and you can see then there was the 8 miles in 2 hours, 2 miles in a half an hour, and we could keep breaking that down, 1 mile in a quarter of an hour, and a half of a mile into an eighth of an hour. Double number lines can come in really handy when you're trying to figure out those fractions of time. But they also do a really good job of showing us proportional relationships. How about this? Someone rides a bike at a constant speed. They go 30 miles in 2 hours. What is their speed? Typically, speed is miles per hour, so 30 miles in 2 hours. The answer would be 15 miles per hour. Okay, so back to the activity. On its way from New York to San Diego, a plane flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix, traveling at a constant speed. We're going to complete the table as we answer the questions and explain and show our work as we can. So here's the relationship. I would like you to put this into the table. This activity gets a little tricky just because of the converting between decimals and time, since there are 60 minutes in an hour, but decimals go up to 0.99 basically before we get back to the whole number. So there's going to be a little bit of converting in time here. So the first question, or the first thing we're supposed to do is to complete the table. So pause the video here, copy what's in the table, and then fill out as much of it as you can. So in 1 hour, the plane travels 550 miles. The speed for that plane is 550 miles per hour. So knowing that that's the speed, and we also know the plane's traveling at a constant speed, we can pretty quickly just move our way right down the table. Remember that speed comes from taking distance and dividing it by time, but we were also told that the speed was constant. So I can actually figure out the speed of this plane throughout the entire trip without knowing the time or the distance. So now the question is, how far does the plane travel in 1 hour and 42 minutes? Now what makes this tricky is that we need to convert 1 hour and 42 minutes into a decimal, and it's not 1.42. 42 minutes is out of 60. So if we do 1 hour and 42 out of 60 minutes, that's the same, if in your calculator you do 42 divided by 60, that's the same as 1.7 hours. And we're going to multiply that by 550, because that's the miles per hour to get our speed, or excuse me, our distance. So 1.7 times 550 is 935 miles. Again, we first had to convert that time into a decimal. Now we want to go the other direction. 330 miles, we're going to divide it by 550, and we get 0.6. So a lot of students wanted to say 6 minutes or 60 minutes, but you have to remember that this is 6 out of 10, and minutes are out of 60. So in order to find out how many minutes this is, we then take 0.6 and we multiply it by 60. The answer here is 36. So it takes 36 minutes for the plane to travel 330 miles. Again, what makes this problem a little tricky is that we have to convert our minutes into decimal and decimal back to minutes. But the constant of proportionality is the number that you are multiplying time by to get distance. Constant of proportionality in this case is 550. The proportional relationship here is that the distance traveled is proportional to the elapsed time, or distance is proportional to time. And again, the constant of proportionality is 550. Okay, so remember from the first activity, we looked at a proportional relationship between meters and centimeters from two different perspectives, right? Millimeters to, or sorry, I think I said meters. Millimeters to centimeters and centimeters back to millimeters. We found two constants of proportionality. They were 10 and 1/10. They were related because they are reciprocals. In the second activity, we were looking at the proportional relationship between the time that a plane is flying and how far it travels. The constant of proportionality here was 550. The constant of proportionality in the context of the problem, remember it is how much of the right side of the table per one of the left. So I know that sounds a little funny, but you'll hear me say that a lot, and I've said it before, but 550 miles, the plane travels 550 miles in 1 hour. That's what the constant of proportionality represents in terms of the context of the problem. Okay, so make sure you check Canvas to see what the homework assignment should be. It is different for pre-algebra or Math 7, and please reach out with any questions.